Lesson 17 is on the area of a circle. So in the last lesson, we were working on circumference, and circumference is the perimeter. In fact, the first example here is a good review of that. It says find the radius of a circle if its circumference is this. So I find it super helpful if we draw a circle. That's not a circle. I find it super helpful if we draw a picture. Okay, so if we draw a picture and it tells us to find, it wants us to find the radius. Now remember, the radius is the distance from the center to the outside. Now this is saying find the radius if its circumference is this much. So we want to always go back to our formula. Circumference equals pi times our diameter. And in this lesson, we're going to be doing a lot of work between pi and diameter, radius and diameter. Okay, so let's plug in what we know. We know that the circumference is 37.68. That equals pi times our diameter. So what are we solving for? Okay, and this can be confusing because we think we have two unknowns, but remember, pi is 3.14159. That's a number. This is a symbol representing a number that we know. It's just irrational. It goes on forever. So the thing we don't know is our diameter. So I'm going to divide both sides by 2. No, I'm not. I'm going to divide both sides by pi. I'm going to get it right here eventually, right? And the reason I'm dividing by pi is pi divided by pi. Anything divided by itself is 1. And I'm left just with d equals. Now, let's be honest. This is not going to be exactly right. It's going to be approximately equal to. So if you were to grab a calculator, okay, in fact, if I did this here, 37.68 divided by pi. See how we get this like really long random number, right? It's approximately equal to 11.99, we'll say. There, done, right? Find the radius. Now, what this tells us is that the diameter, the distance all the way across, is basically 12, right? But we only want the distance halfway across. So to find the radius, we're going to take our diameter, which is basically 12, and divide it by 2. So always make sure you're answering the question being asked. The radius is going to be 6, and it's in inches. Okay, and that's really something we're going to be focusing on today. We're going to be focusing on finding area eventually here. But a lot of times it's going to be giving you the area or giving you the circumference, and it's going to want you to find the diameter and the radius. So always go back to the formulas. Okay? Okay, another little review question here. This one says, determine the area of the rectangle below. Name 2 ways. Okay, well, one way we can find area is using our area of a rectangle formula. Length times width. So our length is 6 and our width is 4, or vice versa. You could say your length is 6 or 4 and the width is 6, doesn't matter. And we get 6 times 4, which is 24. Now, area, remember, is our coverage here, right? How many squares we need to cover it. So we don't just measure it in centimeters, we measure it in square centimeters, and that's why we put that little 2 there. So basically, this means we need 24 squares. We could also get it by counting. The cool thing about rectangles is that we can break them up into squares and count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Hey, guess what? We get 24 square centimeters again. Okay, so you could count. That's not real feasible all the time. So length times width, you get the same answer, and it's a little bit easier. Okay? Now, remember what I said. Sometimes we're going to be finding other things. So the next one says, find the length of the rectangle if the area is 27 square centimeters and its width is 3 centimeters. If that's confusing, draw a picture, okay? The picture tells us that the area is 27 square centimeters. Its width is 3 centimeters. It doesn't know what its length is. Use your formula. Area equals length times width. Plug in what you know. Area is 27. We don't know what the length is, but I know my width is 3. So you see here we have an equation, and when we have an equation, we can solve for our unknown. I don't know what L is, but I know it's multiplying by 3, so I can undo multiplying by dividing. 3 divided by 3 is 1L, and I'm just going to write it equals this way. I like it better. 27 divided by 3 is 9. Okay, that's not area, so we're just measuring it in 9 centimeters. Okay. All right, so now we're going to get to area of a circle. And real quick, I think someone wants to say hi. Real quick. Maybe someone wants to say hi.
Yeah. I want to take over Mommy's YouTube channel. Comment down below if I can take over Mommy's YouTube channel.
Yeah, not going to happen.
Daddy
Say
will have
bye, Jack. Say bye.
Bye.
All right. Maybe I'll make him do math videos. All right, so now we've covered some circumference, we've covered some area of rectangles. Let's do area of a circle, because that's really what this lesson is about. Okay, but we're going to need that stuff we reviewed a second ago. So we have a formula. Just like we have a formula for circumference of a circle, we have a formula for area of a circle. And the formula for area of a circle is area equals pi times the radius to the second power. Pi equals the radius squared. When you hear squared, that means to the second power. So we're going to need to use this formula to find area of circles. Now, this is why it's a little bit different. It's not just length times width. Okay, so let's look at this example. It says use the shaded square centimeter units to approximate the area of a circle. Okay, so you can see here, we can't just put squares on a circle because they don't fit it completely. Okay, so you can see here we have about 3. In here we have 1, 2, 3, 4, 5. And I will just tell you, if you count them, it's 7. That's where we're looking 5. And 8. And another 8. I'm kind of off here. 9, 9, 10, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's another 10 here. 3 tens. Okay, don't stress so much about that. But if you were to count all many squares that were in the circle, this would be 3, 5, 7, 8, 8, 9, 9, 10, 10, 10. What is the radius of the circle? Well, remember, radius is the distance from the center to the outside. So if you look here, if we want to do the center to the outside, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our radius is 10. So using this circle here, using the diagram, how many squares were used to cover 1/4? Well, 1/4 is just this section right here, okay? Breaking it up into 4 sections, just this section. So if I added all of these up, I would get 79. So it'd be 79 squares, approximately, okay? Because again, some of these squares didn't work out perfectly. Now, what is the area of the entire circle? Well, remember, we broke this down into 4 sections, right? So this is 79, this is 79 squares, this is 79 squares, and that is 79 squares. So if I have 4 79, I basically have 4 times 79, right? 4 times 79 equals 316. So we could say the area, we would need 316 square centimeters. Or we can use our formula, because you could see that I had to look at my cheat sheet here to count those squares because they're really little. So if I use the area formula, area equals pi times the radius squared. Remember, we said our radius right here is 10. We can plug that into our formula. Pi times 10 squared. Now this is not 10 times 2. That little 2 here means 10 times 10. 10 to the second power, 10 times 10, that's 100. So this is pi times 100. So remember, we could write this as 100 times pi. This is our exact answer. Or you could type that into a calculator or go 100 times 3.14159. Okay, and if you do that, you get approximately 1.159 square centimeters. Okay, look at how close that is. This is 316. This is more exact at 314. Okay, so the formula is going to give us a little more exact answer. Okay, the things to be careful with is that we're using the radius in this formula, not the diameter, but we know the relationship between the two, and we're squaring our radius, meaning we're multiplying it by itself. So that's what we're going to be working on in this lesson.